So now that we've talked a little bit about what do the graphs of cosine and sine look like, and what are their basic characteristics, we also want to talk about tangent. Now tangent, it's always got to be the weird one. Its graph does not look like a wave. It does not look like sine and cosine. In fact, it even has your favorite. It's going to have some asymptotes on the graph. So there are asymptotes here. Now tangent does repeat itself, but not in that same way that cosine and sine did. They had that nice continuous wave. Tangent repeats itself as well, but it's just not connected. So think of this almost as a rubber stamp, like this shape right here. It's like if we had that on a rubber stamp, if we could move it over and put it back down, move it over, put it back down. It does continue. We just can't draw that forever. So what we have here are actually two repetitions, or two cycles of tangent. So here's the cycle, there's another cycle. And we're going to be, we're going to get familiar with where are the asymptotes and, where are the important points at. But for now, just recognize that general shape. Now, because tangent repeats itself, it also has a period, but it's different, okay? The period of tangent, it doesn't take as long to repeat itself. If you look, this asymptote, so basically our graph right here for tangent, it starts at -90. And it will start to repeat itself once we get to +90. That is a horizontal distance of 180. So it starts with a period of 180. So the idea of the period is the same. It's the horizontal distance needed to complete a cycle. It's just that, like I said before, tangent's got to be weird, Okay. So the other thing to know about tangent is, yes, it has these asymptotes. It has asymptotes at angle measures for which tangent is undefined. We saw that happen from time to time in 13.3, right? If we go back up here and we think about, okay, tangent of 90 degrees, if we think about our unit circle at 90 degrees, here we are, 0, 1. Tangent is y divided by x. Oh wait, we get 1 divided by 0. That's not defined. That's why there is an asymptote there. Okay, that's why that asymptote exists. So I try to remember this. It's going to have asymptotes at -90, +90, and then every 180 degrees after that, because it repeats itself every 180 degrees. The other really tricky thing about tangent is it does not have an amplitude. If I ever ask you for the amplitude of tangent, it is a trick question. You write not applicable. Okay? The reason it doesn't have an amplitude is half the distance between the top and bottom point. If we look at this graph, there is no top and bottom point. It goes up and down forever. So there's no amplitude. So what I want you to do on the next page, first of all, we're going to tweak these directions a little bit. I want you to cross out location of the asymptotes. I just want you to figure out the period. Now with tangent, that's 180 divided by whatever that a value is, okay, or whatever number's in front of theta. So again, I'm not going to ask you for amplitude here on tangent, doesn't exist. If, oh, you know what, I'm going to write this generic form though. If there's a number multiplying theta, you take 180 and you divide by that number, that gets you the period of tangent. So go ahead, try these three and pause the video and then see what you came up with. Okay, now that you're ready to take a look at what they are, here we go. 180 divided by 2 is 90, so that's the period. 180 divided by 2/3 really means we got to flip and multiply. We get 270, and this is weird. You can use a calculator for this, but 180 divided by 4.2 gets you 85.71. Okay, guys, so there's going to be an assignment in the book that I want you to, get a little extra practice with tonight, but you're done for now.